The broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon, wherever you are in the country. It's Mark from SolidCAM. We'll be doing our 30-minute free training session today for SolidCAM Live. With me, as always, Kevin Rankel. Hey, Kevin.
Hey, how's it going?
So today, we're going to do a response to a customer question that we had. I think it was this morning that Kevin got it, so we're going to do it today for SolidCAM Live. And that is basically what you're looking at here. We've got a part that has this nice face here. Now, this is a flat face, but it could easily be whatever shape, whatever surface. But the idea is we want to be able to take our, let's just show the tool here. We want to take our end mill, and we want it, actually, I better tell it that it's mounted in positive X. So let me get out of here. And we want the tool to basically come from the positive X direction and then spiral its way down. So it's almost like we're doing kind of like a wrap geometry, kind of like instead of using a part-off tool or a turning tool or anything like that, we're going to use a milling tool to achieve that same feature. Now on this part, in a practical sense, it probably would be easier just to turn it or something like that. So I made a really simple part, but you can imagine that if you extrapolate this to something more complex, you'd be able to do a cone, a unique looking shape. You can even do specific features. And this is just the idea that you could actually wrap your tool path around the center. So to show you what I've done so far, I actually just roughed it out using that turning tool because this is a very basic part. I just wanted to get some material removed here just to leave enough there so we can see what we can do. And the first thing I tried was a profile toolpath. And you can actually do this using profile. I actually have this set to the spiral. It kind of zigzags back and forth. Didn't really look the best. So what I actually wanted to do was just set this back to constant. You can kind of see that it does give you what you're looking for. It actually just kind of comes down, steps down with each one, and it'll do the job. That is wrap geometry, but you can really only do this with pocket or profile if you have a nice cone shape, not cone shape, the opposite. You have a cylindrical shape, because with wrap geometry, let me just go back to my geometry section here. It's actually being used by somebody else. Okay, that's fine. We'll click new. Whenever you choose your wrapped geometry, you want to make sure you click wrapped first. Now, when I set up my MAC positions, my sub position here, MAC 1 position 2, you can see that I only see my Z-axis. So that's why usually when I train people on wrap geometry or index positions, I always tell them to put the X-axis somewhere where you're going to be able to find it. So X-axis or Y-axis, it really doesn't matter because all you see on the screen is Z. But if I say, for instance, my rule of thumb is to put the X positive going into the part, basically making it the rotary axis from MAC 1 position 2, now when I look at this coordinate system, I don't even have to guess. I know if I wrap it around X, it's going to do what I want it to do. And then all I had to do was just grab my geometry right there. Now in this case, it's a simple circle wrapped around the X-axis. But if I had chain geometry, if I'm doing some sort of contour or something like that, as long as when that thing is wrapped, it has a consistent radius around your rotary axis, it's wrap geometry. You can do it with any of the 2.5D toolpaths. Pocket, profile, 3D contour, you don't want to do it like that, but there's other ways you can do 3D contour. But pretty much anything that could be just wrapped with a simple radius, you want to do it this way. And then once you click that geometry, we can go to our tool like we normally would. You can use any milling tool. So if I wanted to, let's say, add a chamfer on the edge here, I could do that. I could just grab this edge, wrap it around the X-axis, and then get it to do that. With levels, now that we're talking about wrap geometry, we're talking about everything in a radial sense. So there really is no upper level, lower level. This is just outer radius and inner radius of this wrap geometry. But in the mill turn module, you can see that it gave me that cross section. So if I wanted to, I could click on or highlight that and click on this as my outside edge, my outside contour, my outside radius. Or since it is all wrapped, SolidCAM's taking care of that for me, I could just click on this outside surface and get that same value. So it just recognizes the radius of that face. Because again, this is a toolpath when you do wrap geometry, it's pretty much looking for a consistent radius. So as long as I click on a surface that has that, it'll read that for me. And likewise, for that center there, I could, if I wanted to, go to my turn profile and grab that to get my radius. Or again, I could just highlight this and click on that face once again, and it gives me the radius of that face. Or at least the depth, because this actual center here, if I click on this, is actually a 1/2 inch diameter. So 1/2 inch diameter And a 2-inch diameter, basically the radius, the depth that I'm going to be traveling there is that 750. So it's doing the math for me, all based off the geometry. And that green coloring, or on your computer, it might be a red coloring, that indicates associativity. So even though this is wrapped, even though this is relying on consistent radii and stuff like that, there's still a level of associativity here. If I go back to my original part and change this toolpath will always start at that outer radius and go down to that inner radius. The rest of this is the same profile toolpath we've been dealing with. You can just do a left side of the contour. You saw me do consistent radius, consistent step down. I'm doing an equal step down of 100 thou of a finishing pass. And then my link, if I really wanted to, I could add a lead and lead out. I'm just going to add that here. And what you get is something that looks like that. Now, the radial nature of it looks like it might actually be stopping and starting a little earlier and a little later, only because, again, because we're wrapping it, it's not the best projection of the toolpath. I probably wouldn't really do exactly what I want to do here with a profile. But if I want to account for that, remember we have this overlap over here. So if I'm worried about that little gap there, even though this represents the center of the tool, and the angle that the tool is taking probably is actually overlapping there, just to account for that, let's put in a 50 thou. And that kind of just closes that up a little bit, eliminates that witness line that's being developed there. So that's one way to do this, but it's not the, it's fine. It might actually leave some witness lines around there and some rings in concentricity. So maybe not like a witness line, but a witness ring, if you will. Stupid pun. Okay, so let's get out of here. And I think Kevin's too drowsy. He didn't get the joke. But let's say you wanted to do something even better. You wanted to utilize your full ability on this 4th axis machine. This is a mill turn, but this could have been a 3+1 machine. You wanted to get that full consistent movement of the tool. You can do that using your simultaneous 5-axis toolpath. And this actually might be the cleanest one. There's, like we saw yesterday, there's a little extra steps to do these kind of higher level toolpaths. But in this case, we're actually going to be better off because we're going to get a nicer looking toolpath. So what I'm doing here to kind of recreate that, but in 4th axis, is using parallel to curves. So that's going to ask for a surface. So that's the surface right there we're trying to finish. And it's going to ask for a curve to stay parallel to. Now, we're looking at this pretty much in the same way. I've chosen that same contour there. I want to do the same sort of toolpath, getting a little bit more 4th axis ability in there. But I'm still basically just choosing a curve to stay parallel to, just like I kind of did in profile. So that's all the same there. And like we saw when we did HSS the other day, I'm just setting this to the second option here. So full and start at exact surface edges, meaning that the tool will go right to that edge there, right to that edge there. If I were using, let's say, a ball mill or a bull end mill or anything like that, it's actually going to dip the tool past this line here to make sure that it uses the full face of that tool. So it's going to eliminate any cuts on the bottom. But because of that, I might actually need to make sure that I add this as a gouge check surface. That way I don't dip too far and gouge into that. In terms of tool, it's the same tool. You'll notice though that I'm not using macro in position 2 in this case. That is because this is a simultaneous toolpath. So it actually still needs to use that same parent toolpath, that same parent Mac there, macro in position 1. I'm just going to tell it how to orient the tool in this multi-axis toolpath. Levels, well, this is no longer a 2.5D, 3D toolpath, so my levels are now a clearance area to retract to, but I'm looking at this as still being on the rotary, so I'm going to set it to a clearance cylinder around the Z-axis, and we know that this is about a 2-inch diameter. I'm going to set it to a radius of 1.5, so just about ½ inch above the part there, no matter where it is on the part. Toolpath parameters, let's set this at, well, it looks like I had it set at 50 thou, so we'll just leave it at 50 thou there. So we're going to take 50 thou steps across the surface. If the tool is oriented in the right way, that's actually 50 thou step downs around that surface with our spiral. And if I go to sorting, you can see that I have the ability to choose spiral. So instead of doing that one lap and step down, we're going to have a constant Z force all the way down to get that spiral. Now, the reason it says conventional there is because when you generate these sort of HSS or multi-axis toolpaths, sometimes the direction the tool is going is the opposite. So I just set it from climb to conventional. That way, it generated a toolpath that actually came out as climb. It's a little weird, but that's how it is. Tool axis control, I have this set to 4th axis output rather than the 5-axis output. And I have it set to rotary around the z-axis, which in this case is our rotary, and I'm telling it to point towards the rotary axis. So I'm almost recreating what we had with the profile toolpath. You can do this with other ways. If you've got a tool that you don't necessarily want it to be at this angle, you can set the angles any way you want. But this, I find, is the simplest way to generate this sort of toolpath. I just need the tool to point towards the rotary, so I don't even have to control anything about the angle of the tool here, and it'll do the job because I just need the side of the tool to touch this face. But again, if you were using a bull end mill, a ball end mill, something where you wanted another surface on the tool to touch, let's say this is a full 5-axis toolpath, I could actually leave this at 5-axis output and then just get it to angle the tool as it goes around. So there's lots of different functionality in this one toolpath. But for what we're doing here, I'm just going to bare bone it with a 4th-axis output. Everything else on here is very similar to what we saw in HSS. I'll just do a lead in and a lead out. I'll tell it the default lead in lead out is, let's say, orthogonal line, and we'll just do a length of 50 thou like we had before. And I mentioned it before, I'm using a gouge check surface of that cylinder there so that I don't dip the tool too far. I make sure I don't actually gouge that as I go around. And if the tool tip or the tool shaft does gouge with that surface, I'm just going to get it to retract the tool along the tool axis. The tool axis in our case, actually that's still not showing it. The tool axis is the x-axis, the rotary direction. So it'll just pull up in the radial direction. All of that together, save and calculate. And you can see that we have our lead in, our lead out, and we have a spiraling toolpath. Okay, and if we take a look at that in Solid Verify, let me just angle that a little bit so the shading doesn't get in our way. Press play on that. It's doing that first flat just to make sure that it gets those edges, and then now it'll spiral its way inwards. Just speed that up a little bit. Spiral all the way in.
This is a great toolpath for eliminating any witness lines or anything like that, just because we are in constant contact with the material going all the way through it. We're not, doing a revolution, stopping, stepping down, arcing back in. So this will be a lot easier on your tool, but a lot better surface finish this way as well.
Yep. So any questions on that?
Now, if we wanted to, if there was like a radius down in the corner, we could tackle that as well. And that would be pretty much the exact same tool path as what Mark already has done. And we would just pick that drive surface of the radius down there. So if there was a radius drawn in there and we did a flat end mill, and then we wanted to come back with a ball end mill to finish that off, you just pick that chamfered surface as well as the circle for the drive curve and doing the spiral working its way down that way as well.
Yeah, pretty much. If you're using this toolpath, remember that it's using surfaces and a contour. So the contour really just tells it which direction to go. So in this case, I told it to be parallel to that curve. That's why we're getting that nice circular toolpath. It's just being parallel as it goes down. So Kevin's right. If we had a fillet or a chamfer or anything like that, or even if this was in a regular shaped toolpath, as it steps in the radial direction, it's just going to stay parallel to that circle. So it's actually going to give us that nice spiral all the way out. Good example of that would be if I put an actual angle on there, we would see that this toolpath would just turn into a conical toolpath. It still stays parallel to that circle as it works its way in. So you're just driving it by the surface. Sorry, go ahead.
This is done in 5-axis, and if you guys were using a ball mill and we didn't want it to come back and recut all of this, what Mark could do is switch it over to 5-axis toolpath, tilt that tool over by 20 degrees, and it'd do the exact same motion that way. So we're not constantly rubbing on the side, so it gets to a point where we start shanking out a little bit, where we could tilt that tool over at 20 degrees for you as well.
Yep. Might as well just show that since we have some time. So let's do a save and copy. Once it brings it up, there we go, save and copy. Okay, so we'll leave the tool path very similar. What we'll do is we'll just change the tool to a ball mill. Okay, so I'll just say let's just add a 1/4-inch ball mill, just the default one. Well, let's say it doesn't have enough reach. It probably does, but just in case it doesn't have enough reach. So I can leave everything the same, but in the tool axis control sections, like Kevin said, I can just switch this back to 5-axis. Let's say we are 5-axis. Actually, I can leave it at 4th axis and still use the Z as the rotary, but instead of pointing to the rotary axis, let's just put the 5th axis at 45 degrees. There you go. So probably even the same tool path. We just do this. And 45 degrees in the wrong direction, I think. Let's see, 45. No, actually, no. Yeah, I'm looking at the wrong thing. So I have an orthogonal line. That's what I'm looking at. So I'm going to lead out from there. We're actually doing exactly what we want to do there. Okay. Now, in terms of the gouge check, since we're using that ball mill, it's generating a little bit extra movement there. And that's just because I'm telling it to retract in the tool axis direction. This time, I'm just going to tell it to trim out that tool path. So now it just stops before it even touches that surface.
And this is take a look at that. Yeah, may play it through in Solid Verify because this is a great way to not recut anything because we're already cutting with the side of the ball as we're coming down.
Okay, so I'm just bringing up my machine sim, if it'll come up. There it is. Okay, so you can imagine for a machine probably like this, we need it to be a little off because that head is going to collide as soon as it comes too close. But there's our part. And if I just run this slowly, the tool is at 45 degrees, but it's still generating 4th axis code. This is a full 5-axis machine, but just to really simplify the programming, I just said the Z-axis is still the rotary, but the whole table is at 45 degrees. Now the tool just comes through.
Basically what we're doing here is turning our 5-axis mill into a lathe.
Exactly. And there it is. And you can see that it stopped short of hitting the cylinder. So perfect. Okay. So a couple of tricks you can do with the really complex toolpaths when you really limit their travel and stuff like that, add some extra parameters, but it really locks things in easy enough for your programming. So any questions on that? If there are any questions, there is a questions panel, but since we're getting close to the end, I'm just going to put my email, unless Kevin gets there before me, but I doubt it. I'll put my email in the chat section if I can find it fast enough. You can use this email to send us questions, comments, suggestions. One other thing I would say is we're thinking about reducing the number of days per week. So if you have a suggestion as to what days of the week you think you'd like to attend SolidCAM Live, just use this email as well. Please let us know what days you prefer SolidCAM Live to happen. We're going to reduce it from the number of days of every day, basically. We're going to reduce it down to either 2 or 3 days a week. So just let us know what days you think you would prefer to attend. You can also use that email to get personalized training. So if you've got training on the books or you talk to your salesperson and get you purchase some training, you can get personalized training with myself or Kevin or Scott or any of the guys on the team. And it's training based on your schedule. So whenever you're free, just let us know the day and time that you'd like to schedule your training session. We can cover your questions. We can cover your parts. I often say that it's not training time away from your regular time. It's actually work time. So if you've got a part you have to do, you can get us online, get us into a GoToMeeting. We can work on that part with you, and you're getting your regular work done anyway while you're getting trained. It's almost like we're shadowing you while you work on your part. So all you got to do is just take that email and then just send me an email with the day and time that you're free. We can schedule your training session. If you know anybody that can benefit from SolidCAM, let us know. Give them our contact info or give their contact info to us. And then if they get into a demo, I'm going to say until the end of the week, if you do that, you get that $100 gift card. If not, then starting next week or whenever we I guess, and SolidCAM Live, it's going to go back down to that $50 gift card. So it's to your benefit right now to get someone to use SolidCAM and get into a demo. But you get that gift card just for getting them into a demo. If they go into sale, if they become a customer and they buy software, then you get 20% of that sale. And that's always the finder's fee for a final sale. So just getting someone interested in SolidCAM, getting them to be a permanent customer, that's a benefit to you. You get some money for doing that. Like I mentioned, we're going to continue this until the end of the week, every day this week, which is, I guess, until maybe just Thursday, Friday. And then starting next week, it's going to be reduced. We're going to be doing only a few days a week. We haven't determined yet which days. So let us know what days you'd prefer. And that's pretty much it for today. So if you have any other questions, you've got my email. Send me an email with your questions, comments, and suggestions. We'll end the class today. So you guys stay safe, keep your family safe, stay busy. Talk to you tomorrow.
Right, everyone. Have a good one.